In this video, we're going to take a look at the mean and variance of a Poisson distribution. Let's say we have a random variable x which follows a Poisson distribution with parameter lambda. Let's just write that down here. So we have the random variable x which follows a Poisson distribution with parameter lambda. Then the mean and variance of this random variable x would both be equal to lambda. Let's just write this down here below. The mean of the random variable x, the mean of x here, this is the same as the expectation of the random variable x. That's e of x. Like we said, that's simply lambda. And the same is true here for the variance of x. So for the variance of x here, again, let's just write this down. The variance of x, we can just write as var x. Again, this is simply lambda. Okay. Now, like you can see, these results are very straightforward. They are also given in the formula book. So just in case you do forget these results, like you can see, they are quite straightforward. But just in case you do forget these results, they are given in the formula book. So you don't really need to worry about memorizing these results. But it is important to know that this property is extremely useful in determining whether or not a Poisson distribution is a suitable or viable model for a particular scenario. Okay. And what we're going to do now is just take a look at some practice questions here concerning the mean and variance of a Poisson distribution. Starting off with question 1 here then, we're being given the following summary statistics. So I've got n, which is equal to 120, sigma x, which is equal to 600, and sigma x squared, which is equal to 3600. So for the first part here, part A, we simply has to calculate the mean and variance. So for part A then, hopefully nice and straightforward. So for the mean here, let's just write this down, will be equal to sigma x divided by n. So sigma x here, that's 600. Then divide that by n here, which is 120. So 600 divided by 120, that would simply give us 5 there. Okay. That's the value of the mean. We now need the variance. So again, pretty straightforward. The variance here is equal to sigma x squared divided by n. And what we do is we subtract the mean squared. So that would be minus x bar squared. Like so. Okay. So sigma x squared, that's 3600. Then divide that by n here, which again we already know that's 120. And then we minus the mean squared. So the mean is 5, so minus 5 squared. So 3600 divided by 120, that would simply give me 30 there. I get 30 minus 5 squared. Well, 5 squared, 5 times 5, that gives me 25. I've got 30 minus 25 here. And 30 minus 25 simply gives us 5. Okay. We found the mean, that's 5. We've also found the variance, which again is also 5. So that's the solution to part A. So for B here then, it says briefly explain how your answers to part A support the use of a Poisson distribution as a model for these summary statistics. So in this case here, it's like we mentioned at the beginning of this video, because the mean here, which is 5, is equal to the variance, which is also 5, this does support the use of a Poisson distribution. So as the mean is equal to the variance, this supports the use. Let me just write this down in full. This supports the use of a Poisson distribution. Okay, and there we have it. So I don't really need to say much more than that. The key thing to just establish there is the fact that the mean is equal to the variance. Like we said, if the mean is equal to the variance, then this supports the use of a Poisson distribution. Okay, and there we have it. So that's the solution there to question 1. Moving on to question 2 now, where we have a baker who is investigating the number of chocolate chips within a cookie. A random sample of 80 cookies is taken, and the baker obtains the following summary statistics. What we've got here is sigma x, that's equal to 120. We also have sigma x squared, and that's equal to 300. Now, we don't have n given here. We do actually already know n. That's given in the context of the question, and that's the sample size here of 80. We'll just note that down here, n equals 80. So for the first part, again, pretty straightforward. We just have to calculate the mean and variance for the data. So for part A then, for the mean here, and this is simply sigma x divided by n. So sigma x, that's 120, divided by n here, which is 80. 120 over 80, that gives me 1.5 or 3 over 2, whichever you prefer there. That's the mean. We now need the variance as well for the data. So for the variance then, that would simply be sigma x squared divided by n. Then we minus the mean squared. So that's minus x bar squared. Okay. So sigma x squared, that's 300 here. So we do 300 divided by 80. Then we minus the mean squared. So the mean here is 1.5. So minus 1.5 squared there. So 300 divided by 80, that gives me 3.75. Minus 1.5 squared here, which off the top of my head is 2.25. That would give us 1.5 there. Okay. So in that case then, we've got the mean here, that's 1.5. We've also got the variance, which is again also 1.5. That gives the solution there to part A. And then for part B here, there's hence or otherwise determine whether a Poisson distribution may be a suitable model for the number of chocolate chips within a cookie. So again, this just comes back to the idea now of whether the mean is equal to the variance. So in this case, like we can see, again, the mean is equal to the variance. So again, let's just start by stating the mean equal to the variance. This would suggest then that a Poisson distribution would be a suitable model. This suggests that a Poisson distribution, let's just write this down again in full here. This suggests a Poisson distribution is a suitable model. Okay. And there we have it. So that's the solution to A, that's the solution to B, and that gives the solution there to question 2. And finally then, let's take a look now at the very last question here, question 3, where we have Mo, who has conducted an experiment and obtained the following summary statistics. So what I've got here is n, sigma x, and sigma x squared. Now we're asked to determine whether a Poisson distribution is an appropriate model for the given summary statistics. So for us to determine whether a Poisson distribution will be appropriate in this case, what we need is the mean and the variance. Let's start by finding the mean here. So for the mean here, this is simply sigma x divided by n. Well, sigma x, that is 280, we divide it by n, which is 100. Got 280 divided by 100 here. And that will give us 2.8 there for the mean. So nice and straightforward. But we now need the variance as well. So for the variance here, will be sigma x squared. Divide that by n, and then we subtract the mean square. So that would be minus x bar squared. Okay, like so. So sigma x squared, that's 800. It's going to be 800 divided by n, which is 100. And then we minus the mean squared here, so it's going to be minus 2.8 squared. Minus 2.8 squared there. So all I need to do now is just put this into my calculator here. So 800 over 100 minus 2.8 squared. Put that into your calculator, and if you do that correctly, what you should obtain here is 0.16. Okay. So what I've got now is the mean, and I've got the variance. And this is important because we need the mean and the variance to establish whether a Poisson distribution will be an appropriate model. So in this case here, The mean is 2.8, the variance is 0.16. So in this case here, they're not equal. But what that would suggest basically is that a Poisson distribution is not appropriate. Okay, so to state this here, the mean is not equal to the variance. So therefore, Poisson distribution is not an appropriate model. It's not an appropriate. Okay. And there we have it. So, like we said, the key idea there, key idea to establish there is basically whether the mean is equal to the variance. But in that case, because the mean is not equal to the variance, that just tells us that the Poisson distribution is not an appropriate model for the given summary statistic. Okay. And there we have it. So that gives the solution there to question 3. That brings the end of this video on the mean and variance of a Poisson distribution.